Hello, Bio. Welcome to our talk about classification. So what you see on your screen here are three different types of robins. The one on the right is a little bit less similar to the others, but you could argue that they go by the same name. So you see what I might be getting at here, which is that we need an official naming system so that we can discern different organisms. So currently there are 1.7 million species named and described. And it's believed, which is pretty exciting, that there may be a lot more to be discovered as well. How do you take so many different things and organize them systematically so that people in different countries and across the world, different languages, can understand what you're talking about? Enter in the word taxonomy. This is the practice of naming and classifying organisms. And probably the most important taxonomist who lived was in the 1700s. His name was Carolus Linnaeus, and he invented something called the binomial nomenclature system, which for the most part we still go by today. You can see that one of those same robins that we just looked at having a different genus and species name than this other one, with also another genus and species name. And that's really what we mean by binomial nomenclature. Basically that means two names, naming. And so every organism, including you and I, have a genus name, which is the first one, and a species name, which is the second one. We always underline or italicize these, and we capitalize the genus as well. So if you were asking someone for directions and they gave you a description somewhat like this, you might never make it to the location that you're seeking. However, I would argue that this would be a really effective way of giving direction, because regardless of these guys' language or background, if they knew their stuff, then they would be able to identify these different organisms. The really nice thing about using Latin for the genus and species name under the system of binomial nomenclature is that Latin is a dead language. You might say, well, that would make it a really bad language to make your naming system in. But the thing is that it's a dead language so that it's not going to change. And that's what we want. And as mentioned, we're going to capitalize the genus and either italicize or underline both the genus and the species name. So under Linnaean classification, organisms are going to have a different hierarchical structure and denomination. The biggest is domain, and actually for all life forms that exist on the planet, there are only 3 domains that every life form fits under. There are then 6 kingdoms, which you're probably a little bit more acquainted with. So again, the domains: bacteria, archaea, which also includes types of bacteria, and then eukarya. So most of the life forms that you think about, whether it's a mushroom or your dog Spot, as well as yourself, fall under this category of eukarya because we're eukaryotic organisms. The 6 kingdoms I mentioned include eubacteria, archaebacteria, and incidentally, bacteria domain goes with eubacteria kingdom. And then we have archaebacteria, we've got our protista, fungi, plantae, and animalia, and all of those include all different forms of life. Now we diversify out. In the phyla, there are 20 of those groups. One example would be chordata. This would be organisms with a spinal cord. The classification, or the class, would be Mammalia, Reptilia. The order gets a little bit more specific here, as you see something like carnivora. This would include carnivorous animals, flesh-eating animals. And then the family, genus, and then the species coming in down here at the most specific. An example of this would be the organism that you see here, Panthera pardus, so the type of panther, and it's in the domain Eukarya, which I did not show here, kingdom Animalia, phylum Chordata, class Mammalia, then carnivora, Felidae, Panthera, and then species Panthera pardus. So let me ask you a question then. all of the animals in the order taxon, and taxon just means category of classification, have how many other taxa in common? And I'll ask you to pause the video here so that you can think about your answer. So again, all of the animals in the order Carnivora have how many other taxa or classifications in common? You can pause the video now. So hopefully you came to the conclusion that the dog, the panda, black bear, and grizzly bear are all part of the same order as well as the same class, the same phylum, and the same kingdom. So when we say how many other taxa are in common, other than order, we'd have 1, 2, 3 in common. Now, when we go down in specificity to family, genus, and species, then obviously these no longer share these categories below. And by the way, this is keying out a grizzly bear, which is the genus Ursus and species Horribilis. That has a negative connotation. All right, as you see here, there are some different taxonomic classifications that are listed out for different common organisms. So take a look at your own human lineage. Take a look at the chimp, the house cat, the lion, and the house fly. And I would ask you to pause the video now so you can take a look at that. Okay, so once we have the system, it's important to think about how it works out that we actually put organisms into it. Have we come anywhere since the time period of Linnaeus? And the answer is yes, that our system of naming has stayed very similar, but there have been some other types of evidence that help us to discern different organisms from one another, other than just the way they look. And this is important. The molecular structure, we actually can have insight onto the DNA of different organisms, and that reveals true evolutionary relationship other than just the superficial evolutionary relationship that could be supposed by a similar looking beak, let's say. The phylogeny has to do with the ancestral relationship between species. And ultimately, phylogeny is something that we're trying to represent when we name and classify organisms. Now, to further that, the study of cladistics is a method to infer the phylogeny, the ancestry, based on a comparison of shared characteristics. So basically, cladistics is a tool or method to try to infer the ancestral relationship between species. This is an example of how we can use DNA similarities and differences to try to discern different organisms and their evolutionary relationship. Let's say we've got an ancestral species, and here is the DNA represented by both of them. Well, there's a branching that occurs, and this organism now has 2 mutations in a different place that this organism has developed 2 mutations. And then that goes on to form species A, goes on to form species B, and species C. And so we can look and see, okay, well, if this organism here's DNA shares the red and purple bands of DNA with this species over here, then we can infer that they came from a similar branch, more similar than this organism over here. Therefore, this one and this one, both with the same DNA bands, are more closely related, evolutionarily speaking, than this other species. Okay, I want to finish today with a story about 3 birds. We've got the American vulture, the African vulture, and the stork. And I just want you to look and see, which one do you think, or which 2 do you think would be more closely related? If you said this vulture and this vulture, then you would be not alone in that thought. That's definitely, they have similar ecological niches, they eat similar things, their body plan looks pretty similar. But I want to show you something. Originally, scientists agreed with that way of thinking. However, there's more to the story. When the American vulture gets overheated, it does something that I would suggest, you could potentially do if you were in a very hot environment. It might not be so socially acceptable for Homo sapien like yourself, but the American vulture will urinate on its legs so that it can cool off through evaporative cooling. And the stork also does this. So it's interesting to note that even though the stork does not look like the vultures, and we wouldn't normally put it in the same classification, DNA sequencing has actually backed up this hypothesis that the American vulture and the stork come from a closer evolutionary ancestor relationship than the African vulture. So DNA sequencing confirms that, which is really pretty exciting. And again, through the behavioral analysis of the American vulture and the stork, as well as DNA sequencing, we see that these two are closer in their evolutionary relationship than this one. All right, well, that's going to round out our classification discussion. Thanks for joining in.